Two and a Half Admins, episode 193. I'm Joe.
I'm Jim.
And I'm Alan.
And here we are again. Is your PC having trouble? Your smart TV might be to blame.
So this is a pretty interesting one. Somebody discovered that they were having a whole bunch of weird problems on their Windows PC. Some settings weren't displaying, Task Manager sometimes wouldn't open. It was very difficult to try to pin it down to a root cause. And the thing that it eventually got pinned down to was, oddly enough, their smart television. They had a Hisense TV, and the issue is that the Hisense TV kept spamming a different randomized UUID every time it would pull the network, essentially. And the Windows machine was caching all of these UUIDs, and eventually the database of UUIDs that it encountered on the network got so large that it caused performance issues. This reminds me a lot of the issues that I saw when I was testing a home network monitoring product for Ars Technica. We're an Android family in my house, obviously. And when I first set up the monitoring system, one of the things that it does is it builds up a database of all the, in this case, MAC addresses of network devices that it can see. And that allows you to figure out what those devices are. You could assign, labels to them. So for devices that didn't broadcast a host name, but just their MAC address, you could identify it and then, name it like Janice's phone or what have you. The problem was that eventually Janice brought some friends over, and those friends weren't Android folks, they were iPhone folks. And that was how I discovered that iPhones had begun randomizing MAC addresses on every network but their own home network. And the impact there was that all of a sudden my monitoring system was giving me literally hundreds of new device detected alerts every single day because, in the course of somebody being over for an hour or two to hang out, their iPhone would show up as like 20 different devices because of the randomized MAC addresses. So seeing this issue with the database of UUIDs on the Windows machine, it felt very unpleasantly familiar. Also, probably worth noting, I have a Hisense television myself, and I would be worried about that if I let the freaking thing on my network, which I do not.
Yeah, I also have a Hisense TV, and I have never once connected to the network, and I have no plans to.
Yeah, when we were talking about the Roku story a couple of weeks ago, I was like, yeah, I have a Roku TV, but it's not connected to the internet. It's not allowed to talk to anybody to have a new TOS for me to have to accept.
It's a nice thing about having a standalone Roku. You can still be a pretty mainstream normie type and live an easy life and have, the purpose-designed device like a Roku or other set-top box that gives you easy access to the mainstream streaming channels, and all that's fine. But if you get that as a separate device from the actual television, now if it does something that you don't like, you have to replace like a $60 box rather than, your potentially $1,200 television set.
Yeah, exactly. Like I've got an Amazon Fire Stick HD 4K, whatever it is, Max. And yeah, if I don't like that, I can just chuck it away. And I've got my Linux desktop connected to it as well.
Yeah, mine's, I have a little B-Link mini PC that runs the screen. But yeah, like what I did for my mom was took her old TV and got her Roku stick to plug into it because that let her have what she wanted, which was being able to stream stuff from my Plex in her bedroom.
I have both. My current Kodi box is a repurposed industrial controller that got retired, and now it's living as my Kodi machine. That and my Roku are both connected, and I just use the TV remote to pick which one I want.
The other related one to this story is I found something similar with Logitech's G-Hub software on the gaming rigs in my house. It was trying to do something over the network and creating a lot of traffic and a bunch of CPU usage in this like secondary service it was running. And I just nuked it and deleted the executable, and the program still works fine and I can control the LED lights in my mouse, but it's also not gibbering on the network to every machine in earshot about whatever it was doing. I don't know why it was using the network, but it was creating a bunch of traffic for no reason. But this Hisense one is interesting because the way it was effectively creating the denial of service was the PC was tracking every one of those as a unique TV that you could stream something to. And it just eventually, the list of those got so long that iterating over the list would use up a bunch of CPU cycles to the point where when you try to open Display Manager, it's like, oh, do you want to stream to one of this list of 1,000 TVs we've seen in your house? And rendering that list would make the menu take so long to open, it would give up.
Does this count as an accidental denial of service?
It is basically Hisense denial of servicing your PC. Exactly.
I might actually object a little bit to the word accidental there because The thing that's been kind of stewing in my head as we've been talking about this is a sort of a general complaint about the industry in the last few years. It feels like devices have gotten a lot more adversarial. Because when we talk about whether it's a television randomizing UUIDs or an iPhone randomizing MAC address, in both cases, what that really is, it's an adversarial technique. It's saying, I don't trust and I don't like these networks I'm connecting to, and I don't want to give them information. And while a lot of the time we do actually have adversarial relationships with networks that we need to join, maybe you don't want to leak a bunch of information to whatever random public Wi-Fi hotspot you happen to be at. What I don't feel like we have is a sense that any of those devices are actually on our side. Like, it feels like the devices are adversarial to each other in between vendors, and none of them really give that much of a crap about us. If they did, they'd be asking us, like, how do you want to treat this network? Is this a friendly network, or, is this a freaking Starbucks somewhere? And I think that's a useful distinction, and I wish more people thought that way.
This is exactly what Windows does when you connect to a network, right? It asks, is this a home, or is this, a public network?
Yeah, exactly. It asks, is it a public or private network? And I don't know if MAC address randomization is tied to that. I think Windows can do that now. I don't know if it ever gets automatically enabled by itself, but that is exactly the right distinction, which means that Joe has put me in the uncomfortable place of championing Windows as being, the one shining example of doing it right.
Well, let's fire back at Windows and say, surely it should be able to handle this situation better. Microsoft should have taken account of this possibility.
Well, I think it's more the implementation of DLNA on this TV is wrong. It's supposed to have one unique ID specific to that TV, not be, I'll just randomly generate a new one every couple of minutes or whatever it was doing. I guess they probably meant for it to generate a random one once and then keep it, but something went wrong and it just generated a random one every time the service started. So every time they power cycled their TV, it gets a new ID and Windows remembers every TV it's ever seen, which is probably fine when that number is like 30 or something, and not fine when that number is thousands.
Yeah, that's what I'm saying. Surely Windows should be smart enough to go, okay, well, let's save 100 or...
Yeah, and when we see the 101st TV, we'll delete the TVs we saw least recently.
Yeah, exactly.
Damn it, you're making me do it again and defend Microsoft. I think you're expecting a little too much in the way of prescience from them. That definitely seems like something that should be thought of now that we've seen a television do that, but I'm not really going to blame them for not thinking ahead of time that a television might treat the network as adversarial and generate random bogus UUIDs every time it connects.
Yeah, well, it kind of goes back to the old saying that made the internet was be liberal in what you accept, but strict in what you put out, right? As far as like RFCs go. But it turns out the right answer is to assume everybody on the internet is a dick and is going to try to break your shit. And so maybe it is to the point where maybe it wasn't when they built it, but nowadays more devices should assume that the person who made the other device was the most underpaid, overworked developer possible, who barely knew what they were doing.
I get that, but you can't anticipate every possible way somebody else will break something.
Right, but anything that uses up a resource should have a limit on it. Even in that limit, maybe should be higher than you think they could ever reach, but probably does need to be an upper bounds, not just you can add as many items to this list until the computer breaks.
Now we finally got to the point where I agree with you. However, I will again fire back that there are so many things in Windows that should be higher on the priority list than this.
Correct.
I'm not upset that they didn't proactively figure out that some television somewhere would do this and fill up a computer's list of UUIDs.
Mm-hmm.
I don't want them to have thought harder about that specific thing.
But they should push out a fix for this on Patch Tuesday, surely.
Absolutely.
Maybe what it'll take is somebody can make a repo on GitHub that's a little app you can run on your computer and walk around your neighborhood joining open Wi-Fis and blasting all their computers until they freeze by pretending to be a million different TVs.
Yeah, that might have worked 10 years ago, but I don't think you find much open Wi-Fi these days.
Yeah, I guess most people's Wi-Fi comes from their ISP now, so it has at least some kind of defaults.
Yeah.
And more importantly, the routers aren't coming from the factory with the same password on all of them unless you change it. Almost every manufacturer now is putting randomly generated, unique to the device passwords on from the factory.
Yeah.
Because it used to be you could absolutely connect to 99% of the Netgear routers you saw out there with the default Wi-Fi password.
Well, there was that website like defaultpassword.com or whatever, where you just type in the model number of your modem or router and find out what the default was. And it turns out so could anybody else.
Okay, this episode is sponsored by Tailscale. Go to tailscale.com/25A. Tailscale is an intuitive, programmable way to manage a private network. It's zero-trust network access that every organization can use, and with Tailscale's ACL policies, you can securely control access to devices and services with next-gen network access controls. Loads of the late-night Linux family hosts use Tailscale for all sorts, including controlling 3D printers, remoting into their relative systems for support, controlling Home Assistant, and sending ZFS snapshots to offsite backup locations. I got it set up in minutes, and you can too. So support the show and check out Tailscale for yourself. Go to tailscale.com/25A and try out Tailscale for free for up to 100 devices and 3 users with no credit card required. That's tailscale.com/25A. Jim, you've got a wild theory about AI and malware.
I don't think it's actually that wild, to be honest with you. That's the interesting thing about it. So essentially, I think that we're going to be seeing AI malware before much longer. An actual model that looks to replicate itself and make new copies of itself across the internet wherever it can find insufficiently protected space and instantiate and run new copies. I think that this is going to happen for the same reason that the Morris worm happened way back in the day. I mean, it was never a good idea for somebody to sit down and write a virus. The first viruses and worms that were created were not created for financial gain. They were created to see if you could do it because it seemed like a cool thing to do. And sure enough, hey, now we have, self-replicating malware. I think that's going to happen with AI pretty soon because we've gotten to the point where the models, I think, can easily be trained up to the level of like a typical script kiddie. So now all we're really looking for is somebody to have the bright idea and be willing to do it, like literally just to be the first one that made the AI malware. Even if nobody else knows about it, to that one person who does it, that's going to be enough reason. Like, this is cool. Look what I did. And once that happens, once that concept is out there in the world and we've actually got AI models that are not only replicating themselves, but training themselves, it's going to be a similar situation as you have, in any proper biological ecosystem. You've got things in there that you don't like, and they're not easy to root out because they change and they adapt and they protect themselves.
Is it a good idea to even talk about this publicly? Are you going to give people ideas, or are you just assuming that people already have these ideas?
Those ideas are already out there.
For sure.
The world did not need some brilliant person to come up with the idea of the Morris worm in order for Morris to actually write it. People frequently have way too high an estimation of the value of unrealized ideas. Unrealized ideas are cheap. They're pretty easy to come up with. And ultimately, I don't think whoever is going to make this is going to need to have heard me talking about it. I think the idea is really obvious. I think the novel part right now is that not many people in like mainstream sense, not many people have really thought of it yet. And that kind of surprises me because it looks relatively obvious. And it's worth pointing out that there are an awful lot of like free resources out there that you can stand up small models on. You don't have to spend any money or, break a credit card out of your pocket to get some free space on Google Cloud to run a freaking Jupyter Notebook and stand up a model that's doing, text generation, image generation, what have you. It really doesn't seem at all unlikely to me that, like I said, we're going to get somebody's going to train a model to a script kiddie level of capability, and it's going to do everything from find, free to set up accounts that it can instantiate itself onto to, exploiting CVEs and, getting access to places where it shouldn't have access to. The big thing I think right now that limits this idea is the sheer volume of spaces that we don't actually have with enough of the right kind of compute to run a powerful model. But that's becoming more and more common every day. I mean, everybody is pitching AI as the new big thing that everybody ought to be doing and trying to make it easier to get into it and pushing it and promoting it. And it's going to happen. And I think the follow-on impacts are going to be pretty serious because imagine how much more difficult it becomes to get into any kind of like internet computing from the back end side, when all of this like, oh, it's free and it's easy to set up your thing and, get your feet wet is like no longer possible because you've got AI script kiddies out there busily trying to infest every last bit of resource they can find that's insufficiently protected.
Yeah, and even the new Apple M4 chips are AI enabled, and your Windows laptops now come with a Copilot key on the keyboard.
Right. Well, I think especially when laptops start having built-in TPUs or some kind of AI coprocessor type thing, then the malware is going to have a place where on every infected machine, it can get some of this resource instead of having to try to trick Amazon into giving it away for free or whatever.
Although, again, I think the difficulty of tricking Amazon or Google into giving it away for free is lower than you're giving it credit for.
Well, I definitely know it's low. There's a news story we didn't cover on the show about some guy getting sued for having run up a couple $1 million of bills at Amazon and Microsoft's cloud with no money or ever intent of paying them. He just convinced them to give him millions for free, and he was mining some stupid coin on it instead of even doing something useful. He spent like $3 million in cloud bills to mine $1 million in coins, but he didn't pay the $3 million to the cloud people, and they're like, hey, where's our money?
And once we're looking at self-retrainable models doing this kind of thing, I mean, again, it's not hard to imagine not only training a model to do this kind of thing, but, training a model to be able to like look at the list of CVEs and Google and try to find, exploit kits and see if it can use them. That's, I think, a lower bar than a lot of the things that people are actually using, models like ChatGPT for in production right now. Now, modern ChatGPT is enormous, and that obviously limits its scope, and it's very easy to take the contrarian viewpoint and say, why would you do that with AI when traditional code can do the same thing in so much smaller of a footprint? And yeah, absolutely, but it'll be the same reason we do everything else with AI that we do with AI, because it's really easy. And who cares if it's wasteful? Because it was easy.
Part of the reason why phishing attacks are normally not so easily detectable is because they're low effort, and partly because they don't want to spend a lot of time on it, and also because they're trying to target the people that'll be fooled by it. But if you can get AI to make up some of these phishing scams for you, probably going to be a lot more convincing than the ones that the type of people who have no graphical design skill to do it are doing. If every fish is as high quality as a spearfish, then things are going to get a lot more complicated.
And when inevitably, the folks that are using these things, it's not a case of like the AI is crafting it for you, but the AI is just literally directly phishing and spearfishing, then handing you results later, which, let's face it, that's what's going to happen. I mean, you don't get into phishing because you're into making a hard living the honest way, right? That's just not how that works. And once you give these things autonomy, and once you start saying, okay, well, it can do unsupervised self-retraining to become, more, to remain effective and applicable for longer, you're going to lose control of it. And when I say it's going to look a lot like a biological ecosystem, I mean, yes, eventually we're going to have digital organisms that fill the same role in the same ways that parasites do in our real ecosystem. Do we want to have amoebas in our water supply? No, we don't. But it turns out we don't control them. They are a life form. And in the immortal words of Jeff Goldblum, life finds a way.
Yeah, it's like with fleas on cats and dogs, and the old flea treatments just don't work anymore because the fleas have evolved. And so there's only a few flea treatments left that work. And potentially, I suppose we could be in the same situation digitally.
How desperately do we want to get rid of the common cold? Have we made any genuine progress towards it? No, we have not. Why haven't we? Because it can change itself to adapt and overcome whatever specific tailored responses to it we come up with. Essentially, the cold that you got this year is not only not the cold you got last year, it's probably not the cold you got a month or two before that. Now, granted, also, you really shouldn't be getting colds that often, and if you are, mask up.
I was going to say, we did manage to basically get rid of the common cold for about a year there when everyone masked up and stayed home. But that's not really practical, is it? And it's making me think, what the hell are we going to do about this if this nightmarish reality comes to pass?
We're going to do the same thing that we do right now in the biological ecosystem, and that answer is live with it. We're going to do the best that we can to minimize the spread of the things that we really don't like. But we're talking about an eventual world where we do not have control of all of our digital resources, and effectively, we kind of can't. because there's just too much, and there's too much that depends on the system working the way that it does at that moment to tear the whole thing down to get a leg up, on the digital organisms that you want to get rid of. Like, are you willing to take down the entirety of Amazon to flush out a thing that's only doing, X% of monetary damage? And no, you're probably not. You're probably like, that would cost way more money, and I'm not going to do that, which I'll remind you, again, is already the thought process behind an awful lot of the AI that we're using productively right now. It's easy and it's convenient.
The answer probably, sadly, is AI antibodies. We're going to have AI fighting in the opposite direction, trying to find and shut stuff down, or looking at everybody's usage pattern and being like, that one looks like another AI trying to do something.
And we will lose control of some of those that will turn into more malware AI.
Yeah, or some of it will just disable real workloads, bystander shot by the antivirus. And
it'll hallucinate. It'll make bad decisions. It's going to be just like introducing a new life form into a local ecosystem, hoping to, cut the numbers in another one there. Well, there's never any poor follow-on effects there, right?
It's literally the old lady who swallowed a fly.
So what's the timeline on this, Jim? Like, when is this going to happen? Is it happening already?
I don't think it's happening yet. My best guess would be, I think by 2030, we'll at least have seen a proof of concept that escaped out into the wild. Something roughly similar scale to, like, the Morris worm. I think probably by about 2030, we're going to see something along those lines. Now, again, much like the Morris worm, it's not going to change everything overnight. When the Morris worm originally went out, it was like, oh, well, that happened and that sucked, and we fixed it, and that's not a problem anymore. And it wasn't like everybody just immediately went out and had antivirus because that happened once,
Okay, this episode is sponsored by Kolide. When you go through airport security, there's one line where the TSA agent checks your ID and another where a machine scans your bag. The same thing happens in enterprise security, but instead of passengers and luggage, it's end users and their devices. These days, most companies are pretty good at the first part of the equation, where they check user identity. But user devices can roll right through authentication without getting inspected at all. In fact, a huge percentage of companies allow unmanaged, untrusted devices to access their data. That means an employee can log in from a laptop that has its firewall turned off and hasn't been updated in 6 months. Or worse, that laptop might belong to a bad actor using employee credentials. Kolide finally solves the device trust problem. Kolide ensures that no device can log into your Okta-protected apps unless it passes your security checks. Plus, you can use Kolide on devices without MDM, like your Linux fleet, contractor devices, and every BYOD phone and laptop in your company. So support the show and go to kolide.com/25A to watch a demo and see how it works. That's KOLIDE.com/25A. Let's do some free consulting then. But first, just a quick thank you to everyone who supports us with PayPal and Patreon. We really do appreciate that. If you want to join those people, you can go to 2.5admins.com/support. And remember that for various amounts on Patreon, you can get an advert-free RSS feed of either just this show or all the shows in the Late Night Linux family. And if you want to send in your questions for Jim and Alan or your feedback, you can email show@2.5admins.com. Another perk of being a patron is you get to skip the queue, which is what Phoenix has done. They write, I'm trying to avoid using ZFS native encryption together with remote replication to an offsite backup at an untrusted location. The threat scenario is possible data tampering and data theft at that unsafe location. My concept is to use local ZFS snapshots for rollback capabilities and use Restic for storing backups at the offsite location on a simple ZFS dataset. The aim is to have all the nice ZFS advantages locally, but avoid any issues with remote replication and native encryption, while still having an encrypted offsite backup with snapshots, just not provided by ZFS there. Any thoughts on this setup?
So essentially, Phoenix, it sounds like you've got a perfectly reasonable plan. Restic is a very well-known backup and restore utility, well-respected. And you're not doing anything like odd or unusual here. Essentially, ZFS kind of doesn't matter at this point. You're just using Restic to make your backups, and Restic offers the feature set that you want. So that all sounds fine to me as long as your workload can actually handle that. Like, I wouldn't be able to use Restic the way that you're talking about because I have too much data to back up too frequently, and it just can't keep up any other way than block level replication like what ZFS does. But If you can get by with RESTIC, well, you're good to go. The one thing I will caution you about is that in return for not exposing yourself to potential issues with ZFS native encryption, which has less battle testing, I get the desire to avoid those potential issues, but you're trading that for the issues of significantly more complex backup and restore operations. So you need to practice your restores, practice your restores, practice your restores. Make sure that your workload with RESTIC is capable of matching your RPO and especially RTO targets, and that you know how to perform those restores and that it all works fine, and that's pretty much it. The other thing is that since those restores are going to be a lot more complex, you probably need to practice them regularly, where with ZFS, because it's so much simpler, basically once you get the hang of it, there's not really a whole lot that you need to practice and keep an edge on.
Other things I would say is no matter what software you're using to back up ZFS, make sure you're backing up from a snapshot, not from the live file system. If your backup is going to take more than 1 second, then the files are going to be changing while you're backing them up. And you want to, A, get a consistent copy of each file, and ideally have all the files be from the same point in time. And so backing up from the .zvs/snapshot/native snapshot location means that the backup you just took is of all the files as they were exactly at that time. And then using different snapshot when you do the next backup, and so on. But this way you make sure that what you're backing up is actually a consistent view of those files, not just all the files while they were changing as RESTIC is trying to scan while the files keep changing up from under it.
And at this point, allow me to jump in, dear listeners, because I am positive some of you out there are like, you know what? I've just been using like rsync of, my file system, no snapshots, whatever to back up for years, maybe decades. It's always been fine. Like, what are you on about? Well, it basically just means you're not backing up something that changes very frequently or is sensitive to two files being of different versions because, the backup was taking place while those files were being changed. As an example, if you've ever administered a database, for example, MySQL, you will be aware that there are index files as well as the database files. Now, those two need to be in sync. When one of them changes, the other needs to change with it. And if it takes you a couple hours a night to run your backup, the odds are real good that at some point, MySQL will have been changing those files and you'll end up with one version of the index file and a different version of, the ibdata file. And you won't be able to import that database or it will be corrupted or broken or whatever. That's the kind of issue that we're talking about.
Yeah, and it can be as simple as at the power plant when I worked there, they had these Excel documents that referred to other Excel documents. So there's two different XLS files that referred to each other. And so if you backed up one of them at 3 o'clock and one of them at 3:30, then they wouldn't work anymore because they referred to rows in the other one that didn't exist yet or no longer existed or whatever. And it could just break everything.
Essentially, we're just restating the issue as it is, which is that all the files have not necessarily been backed up at the same point in time, but that can cause you other problems. For example, it's not that uncommon to have somebody be like, oh, well, I need to get the file back in exactly the condition it was in at this specific time that I know of when the backup ran, and I don't want it from a couple hours later. Well, if you have a monolithic backup that takes several hours to run, you don't actually know what point in time you're going to have that file in that backup archive. In theory, the files, the timestamp on the file itself, the metadata should be intact. So you could restore that file and check its timestamp and maybe you'd know, but then again, maybe not, because all you really know for sure is the last time it was modified. So, it wasn't modified after midnight, but do you know if that is the version as it was at midnight or 1 o'clock or 2 o'clock? No, you really don't. And in some cases, that isn't a problem. In other cases, it very much is.
And just in general, like we say, you always want to have 3 copies of all your data, and probably one of them should be in a different format anyway. So even in this case, while you're having RESTIC make it over to ZFS, because you're not using ZFS replication Basin, it's a different ZFS, and so not likely to hit the same problem if there was a problem, not that there is.
Well, the other big thing there is that you're not potentially exposing yourself to a waffle-style replication corruption bug, where you have a corrupt file system at the source, and by replicating to the target, you also corrupt the target. Not just you wrote data that was already corrupt, but you corrupt the whole target and make it unmountable. ZFS has not had like a really big disaster like that, but other copy on write file systems, and the most notorious one is Waffle, the one behind NetApp filers, if I recall correctly. That one had a really nasty bug where you could end up getting your SAN corrupted. And if you let that thing replicate to a backup device, another SAN, it would corrupt that one the exact same way. And now both your production and your backup and all the archives, everything is just trash because you destroyed both entire file systems. But in order for that to happen, the corrupted file system really needs to have essentially block level access to the other one, not just file level, block level. And when you're replicating, that's the case. When you're just dumping essentially a big tarball over like Restic, not so much.
Right, well, we better get out of here then. Remember, show@2.5admins.com if you want to send any questions or your feedback. You can find me at joelrest.com/mastodon.
You can find me at mercenarysysadmin.com.
And I'm at Alan Jude.
We'll see you next week.